Okay, Bismillahirrahmanirrahim. Dear students, as we have already done the LC circuit without any source, and you saw that in that case that the energy was oscillating between L and C, just like a mass spring system, oscillation of mass spring system. And in the similar case, you see that if you have L inductance and capacitor C, if they are connected without source, you see that the energy is oscillating between the inductor and capacitor. And the conservation of energy is obeyed provided there is no resistance in the circuit at all. Provided there is no resistance in the circuit at all. Firstly, you saw that a capacitor was charged to maximum value, that is QM. Now, the capacitor began when the switch was open. Now, if the switch is closed, the charge from the capacitor will begin to flow, giving you amount of current. And that current is in the inductor stores energy in magnetic field, that is magnetic energy. In the same, you see that the current flow in the same direction. When a capacitor is discharged completely, that is up to its maximum value, then in that case the whole of the energy is stored in inductor in the magnetic field. Now, what will happen? Now, as the flow of current continues, so it will be used to again in charging the capacitor. When whole of the energy goes to zero in the inductor, at the same moment you will see that capacitor, where there is electric field, will have maximum energy. But in this case, the polarity will opposite. For example, in this case, you see that we have electrical energy in capacitor, and that electrical energy charge begin to flow, and again here we have maximum magnetic energy in inductor in the magnetic field, and again the same energy is transferred to the capacitor where there is an electric field. So the energy oscillate between L and C, and there is no loss of energy because it is assumed that there is no resistance at all. So what will happen if we have, that is the first lecture, electromagnetic oscillation quantitative analysis using differential equation, electromagnetic oscillation of LC circuit using quantitative analysis of LC circuit using say differential equation, with the help of differential equation. Again, you have a circuit consisting of L and C, inductor and capacitor, with no resistance at all in the circuit. Using conservation of energy, that is U is equal to conservation of energy, that is U is equal to UB plus UE, where UB is the energy stored in the magnetic field and UE is the energy stored in electric field. The energy stored in the capacitor is UE is equal to Q square divided by C. यानी ये किस तरह आता है? For example, at the time when Q was 0 on the capacitor, then V was 0 on the capacitor. When it get maximum Q, then there developed a potential V. So the average potential is 0 plus V divided by 2, that is equal to V by 2. You have the equation Q is equal to CV. Q is equal to CV. But in this case, Q is equal to CV by 2. CV by 2. Now, if you have an energy, Q is equal to, U is equal to QV, that is electrical potential energy. then U is equal to Q and V by 2, or U is equal to Q is equal to CV divided by 2, or U is equal to CV square divided by 2. This is the way CV square divided by 2. If you put V in this case, then using this equation V is equal to Q by C. So also you get in the same way 1 by 2 Q square divided by C. In the first case you see that if the value of V in this case is taken average. Why? Because at the beginning when Q was 0, there was no potential across the plate of the capacitor. When the capacitor was maximum charged, then you will have a potential V. So that is why the average potential is taken, which is equal to V by 2. Electrical potential energy between the plate of the capacitor U is equal to VE or QV, U is equal to QV or EV. आप इधर पर क्या पुट करें? एवरेज पोटेंशियल पुट करें तो U is equal to QV by 2. If you put the value of V that is equal to Q by C, then again you will get 1 by 2 Q square by C in this case. So Q by C, 1 by 2 Q square by C is basically nothing, but it is the energy which is stored in the electric field of the capacitor. Similarly, energy stored in the magnetic field is when there is a flow of current across a conductor, magnetic field is developed across. For example, this is capacitor, and here you have an inductor, and this is switch. An inductor, when there is a flow of current, then you see that in the inductor, magnetic field is developed, and the amount of energy which is stored in the field of magnetic field, in the magnetic field of the inductor is UB is equal to 1 by 2 Li square. The total energy present at any instant in oscillating LC circuit is, at any instant, at any instant mean you have a magnetic energy as well as you have an electrical energy, because in this case the energy is not maximum in case of magnetic energy. Energy is not maximum in case of capacitor where there is electric field and energy is electrical energy. But at any instant, you see that the energy is oscillating between electric field and magnetic field. That is why here the word instant is used. So U is equal to, U is the total energy in this case, UB plus UE. If I call maximum energy, then either this UE this will be 0 or UB will be 0. But it is the energy at any instant. It is the total energy. Energy is oscillating between electric and magnetic energy. So 1 by 2 Li square is the energy stored in magnetic field, and 1/2 Q square by C is the energy stored in electric field. Now differentiate with respect to T the above equation. So this becomes du by dt is equal to 1 by 2 L is constant in this case, d by dt of I square plus 1 by 2 C d by dt of Q square, which is equal to, after differentiation you see that it is equal to du by dt is equal to 2 by 2 Li d by dt further derivative of I plus 2 by 2 C dq divided by dt, cancelling 2 2. इसको cancel करें, then you will get the above equation du by dt is equal to L di by dt plus Li di by dt. Li di by dt plus Q by C dq divided by dt. And you can write the above equation is Li di by dt plus Q by C into dq by dt, that is equal to 0. Why it's taken 0? Because there is no source at all and no energy is dissipated across the circuit. Source is 0, the energy of the source is 0. Furthermore, the resistance is taken 0. That is why this equation is equal to 0. This equation is equal to 0. If there was a resistance, then in that case, energy is dissipated across the resistance, then you will take the value I square R. So here we put 0. Why we are taking 0? Because the energy only oscillate between the conductor, inductor and capacitor, and there is no loss of energy. Li di by dt plus q by c dq by dt is equal to 0, or you can write the boy equation is also I as dq by dt. So this is equal to Li d by dt of I dq by dt plus q by c into I is equal to 0. Or you can write this equation is d square q divided by dt square. This one I को cancel करें, taking I cancel, and this I and this I they are cancelling. 1 over LC q is equal to 0, or d square q divided by dt square. 1 over LC is nothing but it is omega square. Omega square q is equal to 0. If you see the equation d square q divided by dt square plus omega square q is equal to 0, it is similar to the equation in the case of simple harmonic oscillator, d square x divided by dt square plus omega square x is equal to 0. Now the solution of this equation is, in case simple harmonic oscillator, which is already done, x is equal to xm cos omega t plus phi. X is equal to xm cos omega t plus phi. X is the instantaneous displacement. Xm is the amplitude maximum displacement. Omega is the angular frequency and phi is the phase angle. So replacing the same equation, this equation, the general solution of this equation will be also in the form q is equal to qm cos omega t plus phi, where q is instantaneous charge and qm is the maximum charge, whether it is maximum charge which has been deposited on the capacitor, and omega is the angular frequency and phi is again same angle, phase angle. So this is way how to find the value. Okay, the stored energy in oscillating circuit is first we take the energy which is stored in the electric field of a capacitor. U is equal to 1 by 2 UE is equal to 1 by 2 Q square, 1 by 2 C Q square. Now what is the value of Q? Q is equal to Qm cos omega t plus phi. Q is equal to Qm cos omega t plus phi. Now putting this value in this equation, 1 by 2 C, Q की वैल्यू क्या है? Qm square cos square omega t plus phi. This is the electrical energy. This is the energy which is stored in electric field. In magnetic energy is, if you see UV is equal to 1 by 2 Li square, or 1 by 2 L, I is dq by dt whole square, which is equal to 1 by 2 L d by dt of, इसकी आप डेरिवेटिव ले लें, ये चूँकि स्क्वायर में आ रहा है तो इसकी डेरिवेटिव ले लें. डेरिवेटिव के बाद आप देख रहे हैं कि आपके पास आ जाएगा क्यू स्क्वायर m by 2 L omega square sin square omega t plus phi. Suppose this is equation A and this is equation B. This one is equation B. Okay. Q square m divided by 2 L cross 1 over LC. From where LC come? This is the value of omega square. Omega, which is the angular frequency, omega has the value 1 over LC under root 1 over LC sin square omega t plus phi. Or this will become, L cancel हो जाएगा, that is equal to 1 by 2C Q square m sin square omega t plus phi. Total energy in LC circuit is, now you will have to take the energy which is in the magnetic field of inductor and plus the energy which is in the electric field of inductor, that is equal to, in case of UB, you have this value, which is already done here. This is from C, equation C, और U E की कीमत जो है इसके बराबर है, जो कि आप देख रहे हैं इक्वेशन ए से। दोनों का सम कर दें, क्या कर दें, सम कर दें, तो सम में क्या आ जाएगा, 1/2 C K स्क्वायर M, टेक इट कॉमन, और ये का स्क्वायर ओमेगा T प्लस 5 प्लस साइन स्क्वायर ओमेगा T प्लस 5, तो ये किस चीज़ के बराबर, दिस इज इक्वल टू 1, so you will get the value K square M divided by 2C, that is the total energy in case of LC oscillating circuit. That was all.